I've been around long enough to know, as a song from Hamilton, I was in the room when they made it. The internet has been evolving since the early 70s, or probably the late 60s. It is a kind of a difficult thing to describe. We all use it, we rely on it, but we have no idea how it works. Unfortunately, I sort of know how it works, but I can't talk to anybody because I live at a very, very low binary level. I understand about logic, and there's just so much, so many layers of understanding of how the internet works that it sort of defies a simple description. So I'm not going to ask these gentlemen to describe what's going on. I thought we'd just talk about things that we do to make a station work across a network, and what do we have to know about the network in order to exploit its capability to augment what we do. Today at the stage, we have Adrian, who you've seen before. We have Bill Fehring, who you're meeting. I think this is the first time you've been up, right?
Yeah, on this stage, yeah.
Okay, yeah, see, Bill comes from the contesting world. He's a member of the ZF1A team and of ND7K and many others. He was spent about a week getting ND7K up and running for CQ Worldwide, CQ WPX phone. Given the complexity of that station, it takes a network engineer, a systems engineer to tackle some of the more complex stations. So he will be later today discussing some of the things that are involved in that process. And also we have the president of the Northern Cal DX Foundation, my good friend Kevin, K6TD, who is with, currently, he retired and then he got absorbed into Elecraft, and he's helping them punch out the latest products from the K4 line, and very much involved in the capability of remoting the K4 going forward through the K40. So they'll be the team talking to me tonight. The message I have to say, internet will never replace amateur radio. That's the first point, okay, that I would like to make. It augments amateur radio in our view. Amateur radio is so necessary because there are disciplines involved in communication or moving information. You have to know about the hardware, and sometimes if you don't have a wired connection, you have to understand about propagation, about how signals get from point A to point B. And now, with the availability of terrestrial networks, you can really provide a worldwide fabric, let's say, so that radio systems can be used if you're in touch with existing data networks. Contesting and de-expeditioning traditionally have been sort of the training ground for, in my view, those who are good at that understand what it takes to create and maintain vital communication systems. I think that's excellent training for people who are, provide public safety support. It's also important going forward that to really complement your knowledge about ham radio, you need to become fluent in networks and how to apply them to your needs. So we're going to start with simply a bunch of simple questions. I'm just going to start the discussion here. Something that's talked about a lot is whether or not you have the sufficient bandwidth, internet bandwidth, to do what you want to do. Based on your provider, if you've got DSL or some high bandwidth, you're going to have different experiences and different capabilities. So Adrian, could you simply describe in general what are the kind of ranges of bandwidth, and what are the kind of things that hams do that need various levels of bandwidth that might be affected by that?
Well, you could use obviously an internet connection to access your home or your remote station, and that's where the main component of the internet is necessary. In this case, it requires a lot more than just a connection. If you get the type of internet connection that's being shared by users in your area, and the times when the usage goes up, then your speed goes down. And so you have to keep that in mind. If you're controlling your station remotely by, to switch things on and off or control them, the internet speed is not that important. But the moment you start transferring audio from the remote location to where you're operating from, then things get a bit more complicated since you have to keep in account the so-called jitter. And that we could discuss in more detail of what that is. But the idea is that to have a remote station that successfully works in a high-speed environment like a contest, or maybe for you to chase some kind of the expedition, then you have to take into account all these details of exactly. It's not enough to say, I'll go and get an internet connection. It takes a lot more research to find out exactly what you're getting, and sometimes you don't have a choice because you can only get whatever it's available in your area. And so that requires a lot more research and thought into the process.
Yeah, in ham radio, there's different, you mentioned with voice transportation. There's more than one way to transport streaming audio across the internet. There's TCP, guaranteed delivery sort of protocols, and then UDP, which are, kind of, if it works, great. If it doesn't, it doesn't.
Correct.
Ham radio, you're seeing the deployment of these ribs that some will use UDP and some will use TCP. What are the differences, and what are the benefits of one and the detriments of that makes it?
Well, the best way, obviously, for streaming audio is the TCP, because this protocol basically guarantees that when something leaves from one point, it gets to the other point. But if some packets get lost because of a connection, then that part gets retransmitted, and it gets retransmitted as many times as necessary for the packet to reach the final destination. The downside to that is, of course, that if you have to retransmit multiple times until the end result is achieved, now you get delay. So with TCP, you get reliability, but if the connection has problems, you get delays. Delays in streaming voice is not good. If it's a CW operation and you lose a dash and a dot here and there, all of a sudden, whatever you're receiving makes no sense anymore. On the other side, you've got UDP, which was invented with the idea, get them there fast as you can. If something gets lost, just move on and keep transmitting go to the next one. So in this case, you achieve the speed, and so the streaming is so nice unless packets get lost. If they get lost, then you lose reliability, and then it becomes an issue, because now you receive the transmission, but it's useless because parts of it are lost. A typical example, this happens a lot with the Wi-Fi connections, where there's interference, and the stated speed that you achieve in those cases is not what it says on the equipment anymore.
Yeah, there's something in human voice. There's an awful lot of redundancy. You can like punch out holes in an audio recitation of a poem, and you get the poem. You don't need to hear every single syllable. So little dropouts are okay, but in CW, you drop that DIT, it's different. There's no redundancy in CW, so it's more vital in my experience of remote operating that the audio quality be as good as you can in order for CW to work well. The minute you start having holes and it causes more repeats, it becomes, you slow down and you get irritated, the rate meter starts dropping, and it's just, but the internet's not the same all the time. There's some times when it's really no problems, and sometimes it's not. Why is that, Bill?
So sorry, what was the question?
Why does the internet slow down at like on weekends?
Gotcha. Okay. So there's a lot of reasons that the internet might slow down. It might be local, it might be upstream a couple levels from you, it could be your street, it could be the ISP, it could be connections between the ISPs, it could be connections between countries, it could be long-haul fiber networks that have been disrupted and traffic has had to be rerouted. It could be attacks that are occurring across the internet. There's a lot of reasons that momentarily something maybe get slowed down. And largely, you don't have to worry about a lot of that because people behind the scenes at ISPs and such are trying to their best. They have paying customers. They're trying to route that traffic as optimally as they can, but it's not always possible. Generally speaking, when you have a medium like an IP connection, or like an Ethernet connection or a DSL or a cable modem, what's happening is you have a fixed amount of information that you can transmit, and if you transmit more than that, you have two choices. One choice is you can drop a packet. The second choice is you can buffer the packet. If you buffer the packet, that means that it just has to wait a little longer before it has its chance to transmit out. And generally speaking, a lot of home devices, home routers and such, have this problem called buffer bloat, where their main choice is to buffer the packets, and as a result, if someone is in the next room watching Netflix and the connection is saturated, then you're going to see your latency go up really high. A lot of, you'll see some products out there like IQ Router and a few other home solutions that will intentionally limit the bandwidth of the network connection just so that they're in charge of the buffer and it doesn't get to that device that's just going to throw unlimited buffering at the problem.
Yeah, I have a rule of thumb on weekends when I'm in contests. My grandchildren cannot do TikTok. Okay, it's very bursty video feeds, and I can tell when they're on my home network. Now, Kevin, we experienced a network issue on Baker that as the contest log grew and grew and grew, and synchronizing of logs between stations became huge data transfer. We started to really slow down our network. What are some recommendations about the equipment needed for a de-expedition so that you can survive a lengthy de-expedition with a huge log file that has lots of busy work going on behind the scenes in synchronization?
Yeah, that's a great question. Thanks, Ned. The point is most of the logging software we use on de-expeditions is the same one we use for contesting, N1MM or N1MM Plus, or sometimes we use WriteLog still. And those protocols are very much, or those logging programs are very much intense with thinking they're on a local LAN that has lots and lots and lots of bandwidth. Even not even across the internet, they're meant to be that. So you have to build your network for the de-expedition like it's a local LAN, which means that you do full Ethernet switching, Ethernet cables, and if you go between the CW and the digital and the sideband sites, you've got to have very good wireless connection. You can't just drop an access point in and expect it to work. Sometimes you have to have a good microwave link between the sites, or in what we did on Baker is we actually ran a piece of fiber between the CW and the sideband tent. So, but that's the consideration, is you have to build it as if it's a strong local network, because that's what the software thinks it has underneath it. So, because the software will continue to use as much bandwidth as it needs, and if you built a network that's so-so, you're going to suffer the consequences pretty quickly as the number of logs grow. And most of the software, they don't expect 100,000 QSOs. They're looking for 5 to 20,000 QSOs because it's built for a networking, for a contesting situation. But if you approach the 20,000 plus size, it starts to be very chatty in terms of what you think the network needs. So that's my advice, is make sure you build your network on the de-expedition as if it's a very solid local network that you would build in your house or in a business.
The other thing we noticed was that the PCs that were Intel Pentium 3 based were choked down very badly, and those that were Intel P5 and higher were fine. So there's a certain amount of processing penalty for that it plays in the network game. Go ahead.
So what happens in this software is that when you have a very large log and you have potentially a lossy medium like a microwave link, occasionally, so a lot of these loggers use UDP to actually do the log synchronization. occasionally something will be missing, and the logger on the other side on the network may realize that, and what it has to do at that point, it has to reconcile what it's missing, and to do that, it has to go through all of the QSOs and find all of the chunks that are missing. And that problem, sort of exists exponentially because every computer on the network actually has to do that with every other computer on the network because it's a full mesh. And that's why, and it's not just a networking problem at that point, it's a processing problem because we have to iterate through each one of those QSOs and make sure that they're actually there.
Yeah, this stems from the fact that distributed databases have been around forever, and people spend a lot of time professionally on that. Particularly Oracle and SAP have spent a lot of time on that as commercial companies because that's what they have to live with. The logging programs were never thought that way, and as Bill noted, a missing piece can cause an avalanche of traffic that the network is just not set up for, and the processors just aren't capable of supporting. So it cascades.
Yeah, and we exacerbated because we had like 13 PCs and 100,000 queues, and it's a kind of a exponential growth in the amount of traffic that was that exceeded our expectations. And then when we looked at Baker and we thought about adding, like migrating to say a Flex, which had additional software that would be running that added more processing demands on the PC. I mean, it becomes I know we're talking about networks, but network access is managed by software and firmware inside the PC as well. It's a component when the traffic starts to become high on the actual processing system. Okay, so we all understand how to find our IP address and get our router configured, or maybe we don't. But that's for accessing internet at home. That's an important step, is being able to define the paths, to make a path through your router so that remotely you can access systems on your home network. Bill, can you explain a simple way of finding out what your IP address is and sort of approaching a router configuration to do remote work?
So, okay. It's becoming a little more common that you may not necessarily have a public IP address, and this is typically something you'll see on 5G networks, LTE networks, satellite networks. So you may not have a public IP address. If you log into your router and it says its WAN IP address is something in the 100.64 range, chances are you're going through something called carrier grade NAT, and you may have to do some other things. However, the first place that I normally start when I'm on a new network and I want to know what its public IP is I'll do a website called ifconfig.me or whatismyip.com, or I'll look at a couple of those and I'll try to figure out if I can do port forwarding, as in, really just try it out. That's the fast way. The other question is, the original question is if it's fixed or not. Generally speaking, if you're not paying for it to be fixed from the ISP, it's probably not. Now, some ISPs are, they'll actually give you an IP address and you'll get it for months, weeks, until you reboot your router and so forth. So it's not necessarily a guarantee that it's going to change all that often, but when it, if like I said, if you haven't bought a static IP address, generally they're going to charge you a couple bucks a month for it, then probably it isn't, especially if you're using DHCP. Now there's lots of solutions to deal with if you don't, so what I would do is get a dynamic DNS provider. There's dyndns.org and a few others where you can just, and generally your router will have some kind of support to update that the host name that you get from one of these dynamic DNS providers, such that you just tell all of your operators or anybody who's trying to remote in to use the host name instead of the IP address. And that's just a really good workaround. Even if you have a static IP address, one day your ISP may come to you and say, hey, we got to change this.
Or you find out that they changed it and they didn't tell you, which has happened to me a couple of times. So,
but then all your operators don't have to change it.
So it becomes a new hobby, essentially, if you live the remote game like I have and most of us have, is that if you have a fixed IP address, generally, if it doesn't change very often, you can rely on it being fixed, and when it changes, you adapt. So if your service doesn't provide a fixed IP address because they don't offer it, or you are using, say, a next Gen 4, I'm sorry, either a telephone access, network access, or Starlink, their IP addresses are not fixed at all. They change routinely. How do you even start to talk about how to make a remote connection to equipment that's inside your home network if you don't have a fixed IP address?
Well, if you don't have a fixed IP address, so the problem is not that it changes. The problem is that you don't know what it is, and if you don't know what it is, you don't know how to connect. It's basically like trying to call somebody on his phone, but you don't know his phone number because it changes all the time. Now, as it was mentioned, the change doesn't happen often. Usually, a few weeks or even a few months from the provider. But for cases like Starlink, they do offer static IP, but it's extremely expensive. Usually, it's used for commercial enterprises and so forth. So one easy way to solve this problem is to use, as it was said, dynamic DNS. You could just sign up for this. It's if you're not too fussy about the name it's being assigned, the domain name assigned to the IP address, you can get it for free. Now, if you want a specific name, like Adrian, Starlink.com, then it's a paid service. It's just a few dollars, so it's not that complicated or expensive to have. So then the idea is simple. Instead of you trying to connect to your remote system using an IP address, then you connect using a domain name, which which gets assigned the new IP address whenever it changes. So from your point of view, it doesn't matter that it changes. And that system is called a dynamic DNS or the DNS. And this way, it's one way of avoiding the issue of having a static IP. And so that easily solves the problem. It's been around for a while, so it's a pretty mature service.
Like who provides it? Where would you look for that? Is AWS or
Go to Dyne DNS.
Dynamic DNS?
Yeah,
Dynamic
DNS.
The website Dyne DNS.
Okay, all right. Now that was in the early days of remote rigs. That was a feature of the remote rig configuration back when that was the prominent way of doing remote access. But they've stopped talking about that. Has it changed from that era? Because I was unable to find it when I was looking for that.
Well, most of the home routers these days have this dynamic DNS feature embedded into them. So in the past, you needed a lot more skills to have this feature implemented, but these days it becomes a lot easier, especially if it does come with the router. Some of these these companies that offer home routers, as a way to incentivize people to buy their equipment, they'll say, well, we'll offer you a free DNS service. And so reading the manual and how to enable that feature of dynamic DNS becomes a lot easier. Again, it's a mature technology, so it's not reserved only for the computer geeks anymore.
Okay, so you've got some bandwidth guarantee from your provider. I know I watch the advertisements on television from my local provider, Cox, and they have this thing, they say that's up to 350 kilobits per second bandwidth. And of course, zero satisfies that equation. So they apparently are protecting me from too much bandwidth. But how do you manage the traffic on your remote connection so that you can send voice without having collisions that interrupt it? What are some recommendations about managing traffic in your home network?
So I typically use Ubiquiti equipment pretty heavily for a lot of my just home networking and such. And a lot of these routers, what they'll have is a feature called you can hear it called a few things like smart queues or something like that. Basically, what it's doing is it's looking at the probability that a packet is going to have to be queued It has to regularly measure the capacity of the link to do this. And effectively what it's trying to do is, as I was sort of mentioning before, protect it from getting buffered by the device in front of it. And as a result, you sort of have an automatic QoS system, quality of service system, that's limiting the bandwidth of the things that are likely to be causing packet drops for time-sensitive services like voice over IP. So that's one way you can do it. I've done this a few other ways. For example, I've made static assignments of various PCs, and I've limited some PCs to only be able to download only or upload only a certain amount of bandwidth per second, and then just sort of reserved bandwidth by exclusion by getting rid of the things that are likely to cause a lot of traffic. You'd be surprised though what actually causes traffic on a network. One of the stations I operate on a bunch is NW6P, and he had a DirecTV box that every, call it 90 seconds, would download a program guide and saturate the link every 90 seconds, like clockwork. And it was just downloading a couple megabytes, but that was enough to cause me a bad time remoting a couple years ago.
Yeah, I was sitting in my TV room watching streaming video, and every once in a while it would pixelate, it'd get behind. And I had a PC next to me watching my station being operated with N1MM, and every time there was an FTP dump of spots, I had a pixelation. It's like FTP was hostile. It doesn't comply with friendly rules about working on a network.
What you're dealing with is a fairness issue in terms of all the different participants on a network. Anybody can use, so TCP by design, by the way, will try to ramp up its usage of bandwidth until it starts seeing packet loss. And the feedback mechanism that it needs to slow down is packet loss. So every single system on your network is doing this every time it tries to transfer any file whatsoever. So it could be FTP, could be HTTP, could be any of those things. It's going to just ignore everything else on the network until it can't get any more bandwidth, and then it's going to start backing off slowly to slow itself down. That's how they achieve, cooperative fairness on a link. And the trick to that is that most of these will overshoot the link a little bit, and everything else will suffer as a result. Furthermore, when you look at most streaming services and video on the internet these days, it's not just one stream. If it's video on demand, or like YouTube or something, it's actually several files that are and several connections that are actually downloading 10-second chunks of the video, and all restarting that ramp up for each of them. That's why you'll see that periodic interruption.
Yeah, the solution always seems to generally be just buy more bandwidth, but sometimes it's even what you have gets overloaded.
Well, by design, it's going to try to use all of it.
So everything grows to fit the available capacity.
Yes.
Number one rule of engineering: everything grows to fit the available capacity. One more. There's one more rule. Yeah.
Okay, as we've been talking a lot today, one of the critical issues in transporting audio and keying information over the internet is the critical timing. All of us learned to send CW with audio feedback. With a hand key, you needed to hear a tone. Your ear told you what you needed to know, and you decided when to press the key, when not. And when we migrated to keyer paddles and iambic keying, we've been trained on how to send beautiful CW using all of these lavish devices. And then today we throw in network delays into both the audio feedback from whatever local keying thing you've got, and then what your radio might be doing, which is delayed some amount later. In a system like the Elecraft K4, Kevin, how do you manage how do you steer the design to make the operator be able to send CW remotely from a
So
K4?
for CW, the only solution we found is local side tone. Because if you do remote side tone, you just don't get it. You're so out of sync that I can't keep the paddles working correctly. And I don't know anybody else that can. So it's usually local side tone for CW. And then you sort of have to mute what the remote radio is doing. It's the only way you can keep up. And both Illicraft and Flex have come up with schemes for that. Flex not so much as Illicraft, but there's been a lot of other schemes put on the market that support local side tone for CW keying, even though it's going remote.
Yeah.
And there's a couple schemes for sending the remote CW. One is the K1 or the W1EL scheme or K1EL scheme where you convert it to a character and send the character. You know, you listen to the CW and you figure out what the character is and send it. The other is so that you recognize the fist of the guy as they want to send the dots and the dashes. And the dots and dashes are much more problematic to losing one of them, as you noted earlier. So both schemes have the problems. But the only way to do it locally is to do a remote CW is to do local side tone.
It's something I've learned. My remote station, I know Kevin and I both have built remote contest stations. His is done in Silicon Valley, where bandwidth is infinite. Mine's out in the middle of nowhere in eastern Arizona, and I've got a ma and pa internet provider, and I have to deal with wild gyrations and jitter and delays, and it's just a different experience. And so my station evolved one way, and his evolved a different way based on the available internet. For example, we don't do any remote paddle operating CW. You can start a dash, but you have no idea when it's going to end when you use remote rig because of the jitter.
We don't either. We gave up on that.
Yeah, so CW is really great. Also FT8, if you don't generate the audio at your home or where you're on your laptop you're connected to, if you send audio, there'll be jitter, and FT8 decoding gets seriously degraded. So the way around that is to not transport audio, if you can avoid it, across the internet. Generate all the data-based tones for FT8 locally. Operate at a higher level on CW, send request messages to be sent, or send keyboard data and let N1MM create the keying locally, and not task your network to do that. But voice, you can't get around it. You've got currently, but there's some changes coming in AI generated voice that will permit local generation of audio at some point in time later. Something that we all lived through the metrification era, right? How many years have we been worried about all of us going metric, right? I think the new thing for today is transition to IP6. At some point, the very last IP4 address will be issued, and we're done, right? But the next generation is IP6, where you have more larger address. Do we need to be concerned? Like, I understand that Starlink is essentially IPv6, and do we need to be concerned about a migration to metrics, like in the internet world?
Well, my personal view is that that's not going to happen anytime soon. I remember when I took my first Cisco certifications 20 years ago, they were asking exactly the same question. We're going to run out of the IP version 4 addresses, and, expect that tomorrow morning you're going to wake up and everything is going to be IP version 6. But the internet, with so many billion devices connected at this point in time, an upgrade of this magnitude will impact it so much that most of the vendors are not going to be pushing it for a change anytime soon. Now, there are implementations of IP version 6, large companies and some other places that have large networks, but generally the public and the internet that we all see nowadays in our homes and our devices are not really going to be IP version 6. So from my point of view, I don't think the migration will be so drastic that we have to worry about it.
So you think if you're on a home network with a router, IP6 may exist on the WAN side of your router, but locally will always pretty much be operating IP4?
Yeah, yes, that's correct. Because there's so much equipment that is already on the market that people use at their homes. You know, if things are changing to IP version 6 all of a sudden, then all these devices become incompatible. Of course, if you're a tech geek, you always figure things out on how to make it work, but the vast majority of the people won't be able to. So I don't think the push, if it will happen, it will be so drastic that we need to plan for it.
Is there any topics any of you guys want to raise?
Sure.
Yeah.
So for IPv6, so the internet ran out of IPv4 a little over a decade ago at this point. The only way that IPv4 happens for the new ISP is the secondary market for IP addresses. It's about $30 to $40 an IP address, and you buy a minimum of 256 at a time. So it turns out that a lot of eyeball networks, like your home internet providers, have been actually using IPv6 and handing the addresses out for years at this point. It's a lot of large service providers, content networks, Apple, Microsoft. Largely, you have an IPv6 address in many cases, and you're using it transparently, and you don't even know half the time, right? And this is sort of where there's an economic question for the ISP. Do I continue letting everybody have their own unique IPv4 address and, you know, eating that cost, whatever it might be, or do I, you know, move them over to CGNet and then they get a unique IPv6 address, but they have to go through NAT to use IPv4. And that's just the reality, and I'm sure as the cost escalates, that question will be answered differently by different ISPs. And, you know, some sooner than others, and just depends on the scale and how often it's happening. You know, I don't see a lot of support for IPv6 and ham equipment. I don't know that we really need to worry too much about it. IPv4 networking is probably never going to die.
I had a couple comments. One is there were two design points on IPv6. Modulo the number of telephones in the world so that addressing was not an issue. As Bill noted, the address space is much bigger, and they've worked out a hierarchical scheme that works very well on IPv6. The other design point with IPv6 was no need for a firewall, that everybody had direct, well, Bill's laughing because he knows the story. Everyone had direct connections. Google tried that, didn't work for them very well. No one has done that. It just hasn't worked out practically because everyone has learned how to use IPv4 NAT. So, and there are even larger ISPs now, not giant ones, but larger ones that don't offer IPv6 because they've done it fine on IPv4, and most of their customers use NAT. So, concerned about it, concerned that I don't think there's any ISP that's going to tell you you only get an IPv6 address. There are some that are doing CGNAT that are IPv6, but you have a different problem there.
Well, yeah, there are ISPs that are only giving you a v6 address and then actually doing network address protocol translation to fake, you know.
Yeah, Amazon's doing that now.
Yeah, you know, make everything appear to be an IPv6 service through DNS tricks and so forth, but yeah.
So are there any questions from the audience?
Say it loud, we can't hear you from up here. The guy in the green.
Yeah, so give your name and call.
Oscar Hotel 1 Sierra Charlie, Sierra Mike 5 Sierra Charlie, Göran. The fourth point you jumped over about UDP, was that intentionally or a mistake?
No, we covered it earlier, like in the second question, but
we covered it at the beginning.
It was like 8th on the list, yeah.
So the big difference between UDP and TCP is sort of the end-to-end systems design. UDP very much depends upon the end system figuring out what to do. TCP takes care of all those issues for you, but there's trade-offs to it. Yeah. So you have to look at how the system was designed. I will tell you that the Flex Radio Systems guys depend upon UDP, the Elecraft guys depend upon TCP, and they've both been very successful at it. So it's kind of how it goes.
I'm Palle Oscar Zulu 1 Romeo Hotel. At our contest station Multi Oscar Zulu 5 Whiskey, I would like to address the security of IP radios. The remote operators can change any parameter in the radio. If they change the IP address of a radio to one of the other radios, then we have two operators complaining nothing works. But they can also, that's easy to figure out, but they can change ADC characteristics.
Some of this is solved by human engineering.
So the radio doesn't perform very well. I think it should be addressed as different levels of operators, a sysop, remote operator, and so on. But any solution?
So the,
Could you repeat his question?
yeah, his question was, is how do you keep remote operators from changing critical design parameters in the, or not design parameters, but critical operating parameters? And Bill's got it right. It's social engineering right now. Almost all the radios designed today were thinking of one operator. They weren't designed to support multiple operators. That'll come, though. That'll come. They're all thinking that and thinking about how to do profiles or operator controls. And some controls can be changed by a master operator, so to speak. Some controls can't be changed by a local operator. That's a long ways coming. So.
I'm Mike, NA6MB. You skipped over the second to last one on your questions there. How do you measure the performance of the network? How do you check when a dropout occurs? What happens? Can you put another device on the network that watches the speed or something to say, oh, I had a dropout at this time, and oh, I looked at my log, and this is what happened at that time?
So there's a whole slew of tools that I use to do that kind of thing. One that I like a lot for Windows is called Ping Plotter, and it's free-ish. I mean, there's a version that does enough for what you're doing, and the free version usually can do what you need. But basically, what you're looking for is, yes, you're looking at the latency. You're looking how consistent the latency is, and how consistent it's not is called the jitter. And you're looking for drops. Now, if you need to do that over a much longer period of time, unless you're comfortable in a Linux environment, this might not be the best tool for you. But there's something that I've used traditionally called smoke ping. And I have a piece of a server running that's just watching this over days, weeks, months, to sort of tell me what the trend is. But that's also another reason that I like all the Ubiquity stuff, because it's largely building a lot of that in now, and it's doing a daily speed test. It's showing me latency over time, and I don't have to set any of that stuff up.
It's something that I use to try to figure out what problem I'm trying to solve is I do a trace route, which sort of analyzes the nature of each of the regeneration points in a network. Is there something that you've used that's similar to that?
So traceroute's a good tool for just telling you what paths you're going through, but it's only, first of all, it's only going to tell you one direction, and the latency numbers aren't necessarily need to be taken with a grain of salt, because the way that traceroute works is it's relying on an exception mechanism, and that's not always a priority for a router that's sort of in between you and your final destination.
Yeah. And is it true that a ping always travels the same route as, say, a TCP connection?
No, it's not. Not even a little bit, unfortunately. So the trick is with different protocols and even different IP address mixes. So in large ISPs, there's almost no such thing as a link that's big enough these days. So what they do is they hash packets across bundles of links, and different source destination, different port, different protocol may end up on one of several 100 gigabit or even 400 gigabit links going across the pond, and and any one of those could be congested, and it will probably even differ in the reverse direction, and it may not even go through the same set of ISPs in the reverse direction. So it's a little hard to troubleshoot that stuff if you're not paying attention to it with the exact same port protocol IP and.
That's what I would do. I would do trace routes from both ends and then look at the data and see what's going on. Now you guys see why these guys are paid so much, because you have no idea what they were just talking about, but you're sure glad they do know what they're talking about.
You can't do a trace route from a radio, can you?
No, you can't. But
only if you can log into it.
Yeah.
But you can from the same network the radio is on.
Yeah,
offers
a computer
that.
in the
You just have to
network.
know how to do it.
Yeah.
Israel, K7NO. Bill, for this purpose that we are discussing here, can I use Wireshark?
So Wireshark, you can use it. It's a little more difficult to do an analysis of whether a packet is there or isn't there. So here, let me tell you what Wireshark is. Wireshark is a tool that will watch a a network card and show you a visual depiction of every single packet that's gone over it. And you can look at the packets, you can look at the fields in them, you can look at their payload. Now here's my question to you. If a packet's missing, how do you know that it isn't there? Usually with something like ping, you sent something and you're expecting an explicit response. So if you don't have something that you can say, okay, this is, I sent this and this is supposed to come back, that's sort of where Wireshark's going to fail you, at least looking for loss. Now looking for I'll tell you a story about a really interesting one that we had at N6RO once. And we found out that the ISP's equipment was occasionally duplicating a packet. Like it was just sending the exact same packet twice. And the remote rigs have a bug in them that if you do that just enough, the remote rig will restart in the middle of a stream. It'll just hang up and crash. It cannot deal with duplicate packets. Duplicate packets should never happen on the internet. There's no reason that should ever exist. So not surprising that the guys that made remote rigs didn't test that. But it was a thing and we had to do something about it. I ended up using a VPN to fix it, but Wireshark was my best friend in finding that problem.
Well, one thing that I wanted to add about Wireshark is that it's a free tool. So if you know how to use it, use it properly. It's not something that you can figure out things like he was mentioning double pockets, and these are complicated things. You need to have quite a background in networking to figure these complicated things. But most of the time, what you're looking for is you have a remote station and all of a sudden you get these drops and you don't know where they're from. Are they from the provider? Is it some computer in your home that is misbehaving, or your kids watching Netflix on 3 TVs? So for that type of stuff, a free tool set up properly will answer that question. Also if you set up the network properly where you can easily troubleshoot it, in the sense that, okay, let's say you have 5 computers or 5 devices and all of a sudden you see 6 devices, then that's something that's easy to troubleshoot with Wireshark. Also, a lot of mistakes that are being made is that on the network that needs to be reliable for remote operating, you've got maybe a Wi-Fi set up, so people are coming and going and playing on their phone. All of a sudden, you get half of the bandwidth used for something else. So you don't have to go crazy with complicated tools. With the simple tools, if you get fixed 90% of the problems, then it's still a win.
The first tool you mentioned, did you say it was Ping
Plotter?
Ping Plotter, yeah.
Thank you.
Or MTR or WinMTR are all similar things.
Let me ask you a question. How much security vulnerability do you add when you start adding port forwarding to your router?
Well, you are exposing it to the entire internet, and it takes only modern software. It only takes a couple of seconds to scan the entire internet. There's a company out there called Shodan that publishes. There's a search engine for internet scans to find vulnerable devices. Now, most of the stuff we use in ham isn't all that interesting. I have seen a couple of interesting cases where we had our green heron everywhere set up at ZF1A port forwarded and exposed to the internet, and occasionally one of the random things scanning the internet would do is connect to it, and it would stop responding to all the commands for our stack meshes and stuff mid-contest. Even if we were only in person and there was nobody remote, we just happened to have it port forwarded, and as soon as I turned that off, that stopped. So, I would personally prefer not to expose anything if I don't have to. It's sort of, you are taking a little bit of a risk, but you are getting a little bit of security by obscurity just because of how common what we're even doing is.
Is it advisable to consider something like a virtual private network to avoid that sort of problem?
So you're not necessarily going to avoid it with a virtual private network. I have 3 patents in virtual private networks. That's actually what I work on for a living is VPNs. And it turns out that VPNs, by the way, can also be, when you put a VPN on like a router, they can have vulnerabilities too, okay? And sometimes the router can get infected, and there's a lot to that. Now, it may be just another, and by the way, a lot more people use VPNs than random ham equipment. So there are some vulnerable VPNs out there, and there's a lot, since people put more stuff on their private network than they do externally, from an attacker perspective, there's a lot of benefit to be gained from breaking into a VPN. So is it protecting you? Maybe a little bit, but you know, don't put all your eggs in that basket. Now, one thing I will tell you about VPNs, though, and one thing that's very handy about them is that sometimes on the internet, the most direct way between 2 points is not a straight line. Sometimes, if you put a VPN concentrator, say at a cloud provider, and you have a VPN from your QTH to there, and then all your operators log into the concentrator it's in the cloud provider, you might actually get better latency and better reliability on the link that way, believe it or not.
Wow. Okay, are there any other questions?
Non-standard port names, good idea.
Again, the scan happens so fast these days that it doesn't matter.
Mike, W7RIS. Question is on Wi-Fi. A lot of times in events you have networking that is all based off of Wi-Fi. Is there any minimum requirements that you would say, or minimum level, like Wi-Fi 5 and 6 have really improved things. Wi-Fi 4 has really complicated things. So is there any basic level that you would think that should be there?
I'll answer that one real quick. For radios these days, I wouldn't use Wi-Fi at all. Sorry, it just doesn't work. It's got too much variability in it, and if you look at the protocols that the Wi-Fi is built on, you would sort of gag. So.
Yeah, never send a wireless connection to do a wired connections job. And what I would also tell you, so I have a coworker that used to work on Wi-Fi modems for a living, and he told me this, and it shocked me, just to echo what Kevin said, is that you can have two Wi-Fi modems connected via coax with just the exact amount of loss that you need, and you will still lose packets by design. Now, the other thing about, when it comes to jitter and loss, Wi-Fi modems are always trying to tune themselves. They're always trying to see, okay, if with this amount of signal to noise ratio, I can use this modulation. And they may change their mind, a couple times a second, and potentially that will, just that changeover will make the latency a lot worse, or the jitter a lot worse. So like for VoIP, for sure not. For things like even logging connections, I was at KM7W once, and we were having all these problems with DX logs synchronizing during our contest, and I said, you know what, I pulled a wireless cable out of my bag, connected the two PCs together, and that solved all of them. So yeah, just if you can help it, don't.
Well, what you have to keep in mind, those Wi-Fi types that you mentioned, the difference between them is the speed, but the speed is not usually the problem. The problem is the jitter. And the Wi-Fi connections, the jitter is really bad, from the point of view of streaming audio.
Yeah.
So everything that you've mentioned so far, that's exactly the reason I don't like using Wi-Fi.
Yeah.
Yep.
Very good.
So why'd you ask the question? It's okay.
All right, are there any other questions? Yes, sir.
Absolutely.
No,
Absolutely.
Yes,
It's, my tower. So the question is, since the Wi-Fi is now reliable and wiring is a better option, what about using fiber optic instead of copper wires? So obviously, fiber optic is the best approach because it's glass. It's not influenced by water, so it just works perfectly. Lately, the fiber optic cables are extremely cheap, and so it's reliable, and it's not influenced by magnetic fields, so you don't get interference from that. And so it's a good approach if you have the ability. It doesn't work everywhere because of how things are set up, but at my tower, I'm connected just by fiberglass. And so never had any issues or interference.
There's a class of routers that have the media converter option for the cable interface, and then you also have to deal with the tools to cleave the cable correctly and mount the adapters. So it's a step, a big step, but the payback is tremendous because we all fight the birdies. We know exactly where all the birdies on are every band that are related to Ethernet annoy us that they're there.
It can happen in the reverse too. You can have enough power to, QRM your Ethernet as well. But also I would say that there are not a lot of PCs or even small form factor PCs that have an SFP port in them. It's sort of rare. So you're going to end up buying a media converter, and then you're going to have this little, 1 foot pigtail of copper, and you've already lost the game, unfortunately. If you're going like long distances with Ethernet, by all means, my
if you have a remote building or something like that, yeah, definitely. It's better than a wireless link out to that building. Yes, definitely.
Remember,
okay.
We did that on Midway.
Okay, so we're going to break for lunch. We'll see everybody at 1 o'clock. Thank you very much. Hope you picked up some tidbits here today. So thanks, 73.